Hi all, my name is Shankar and today we'll talk about topological sort. Let's get started. Before you start understanding topological sort, I want to make sure that you understand depth first search, for which I posted a video around 10 days back. If you don't know that, you can check out the card on the top right corner of your screen. So before moving to the algorithm for topological sort, I want you to understand that topological sort is nothing but just the printing of all nodes of a directed graph which is acyclic, and each edge is such that the tail node must be printed before the head node. One more common observation is that we can only print topological sort of a graph if and only if the graph is directed and acyclic. Otherwise, there will be cycle that this node must be printed before this node, must be printed before this node, must be printed before this node. So they all are just kind of fighting for you first, you first, you first, like that. If you understand this, then let's move to the algorithm. So, what is this algorithm and what is this NWOIE? So in this algorithm, we have to do just two things. Firstly, we have to do DFS from all nodes without incoming edges. So our first objective is find all nodes without incoming edges and then do DFS. It seems simple, right? This is our first task. And secondly, write this line at the end of DFS function to store result in stack, or I should say in a stack. Stack dot push this value. I'll tell you how. I want you to repeat this. First, do DFS from all nodes without incoming edges. DFS from nodes without incoming edges. Then store result in stack. Okay, two simple lines for complete algorithm for topological sort. If you can understand this, then let's move to code part. So here is the code part. In main function I first read number of nodes in graph, then number of edges, and then I created an adjacency list as an array of vectors. For total number of edges, I read from and to as a and b, and then I stored that in my adjacency list. After that, I called topological sorted print function that I just created over there, in which I passed just two parameters, adjacency list and number of nodes in the graph. Let's see how this function works. So here's the function. I first created a boolean array simply to store where I have NWOIE. Okay, then I created this line which basically says that we can start from every point, and then I traverse through this entire adjacency list, and whichever node is adjacent to any other node and that has at least one incoming edge, so I'll mark that as false. And now I also create a stack of integers simply to store my results in stack, and a boolean vector which says whether a node is visible or not, visited or not. Then for entire number of nodes, if we have that place as NWOIE, then do DFS. Simply, I'll pass the stack, adjacency list, visited array, and the node itself. Now, what is this DFS function? It is a simple function which first marks the current node as visited for every neighbor which is not visited by now. It will call DFS function, and after this whole thing at the end, it will write this line: push current node into stack. And after this, we can see the output that will be right. So this is it. Firstly, I want to ensure you that this algorithm really works and it is tried and tested if you are thinking that how is it working. But let me tell you the glimpse of how it works exactly. So if I have some nodes, say like this, and another node coming like this. So what I will do, I'll first do DFS for this whole thing because it is first or any node without incoming edge. And then what I will do, I'll first store it in stack like this, and then all whatever is there in the graph, that will come above this. So whichever is prerequisite for any of these nodes will definitely come above them. In this stack, we are always storing nodes which are prerequisite above the node whose prerequisite is that node. So first I'll store all this in this stack, and whatever is remaining can be prerequisite for any of these nodes. So all of them will stay above this stack. And after all this, I'll print each element number wise, and that's how I'll get the result. Now let me tell you this straight away. This algorithm is actually really easy, but you might need some time to understand this. Digest what I told you in a minute, and if you understand this, then good luck. Now you understand what is topological sort. See you soon, goodbye, and make sure to like the video if you like it and subscribe to this channel for more such videos. Goodbye.